We have a phrase in English language that we use to describe the absolute pinnacle of human intelligence. When a task is incredibly simple, we say, come on, it's not a rocket science. We elevate the rocket scientists to a status of modern-day wizards. We assume that the people who build machines capable of escaping Earth's gravity and traveling millions of miles through the freezing, irradiated vacuum of space are infallible. We assume they operate on a level of mathematical perfection that normal human beings cannot even comprehend. But human arrogance is universal constant, and it turns out you can have a PhD in astrophysics, you can work for the most prestigious space agencies on the planet, and you can still fail a 4th grade math test on planetary scale. Welcome to the Conversion Void. Today we are traveling back to 1999. We're going to look at the Mars Climate Orbiter, a 125 million marvel of human engineering that was supposed to revolutionize our understanding of the Martian atmosphere. Instead, it became the most expensive, embarrassing shooting star in the history of solar system. Why did it crash? Was it hit by an asteroid? Did a solar flare fry its circuits? Did the Martian aliens shoot it down? No, it crashed because the smartest people on the planet forgot to check if they were using inches or centimeters. In this video we are going to explore the ultimate triumph of bureaucratic stupidity over orbital mechanics. We will look at the fatal crash between the metric system and the American freedom units, and how a simple failure to communicate vaporized a decade of scientific research. Put away your calculators, math is dead. We're going to Mars. To understand how you accidentally incinerate a spaceship, you have to look at how it was built, and more importantly, who built it. In the late 1990s, NASA was operating under a new philosophy championed by their administrator Dan Golden. The motto was faster, better, cheaper. Let me give you a piece of universal advice. Whether you're buying a used car, getting a tattoo, or buying an interplanetary spacecraft, you can have it fast, you can have it good, or you can have it cheap. You can pick two. If you try to pick all three, you're going to end up with a flaming pile of garbage. The Mars Climate Orbiter was part of this new budget-friendly initiative. To build it, NASA Jet Propulsion Laboratory, JPL in short, in California partnered with the massive aerospace contractor Lockheed Martin in Colorado. This is where the Imperial void opens up. Science as a global institution operates on the metric system. It makes sense. It scales by tens, it's logical, clean, and universally understood. NASA's JPL, being a serious scientific organization, used the metric system. Specifically, they calculated the force of the spacecraft's thrusters in Newton seconds. Lockheed Martin, however, was an American defense contractor, and America has a deep, pathological, almost romantic obsession with the Imperial measurement system. Lockheed's engineers programmed the software that controlled the orbiter's thrusters using pound-seconds. They built a $125 million spacecraft, and half the team was measuring it in bananas, while the other half was measuring it in apples. And nobody checked, nobody bothered to write a single line of code to convert the units. They just plugged the Lockheed software into the NASA computers, patted each other on the back, and launched the damn thing into the cosmos. On December 11, 1998, a Mars Climate Orbiter blasted off from Cape Canaveral. It had 28 6-day journey ahead of it, traveling over 460 million miles through the dark, silent void of space. During this 9-month cruise, the spacecraft had to make several trajectory correction maneuvers. Space is big, and if your aim is off by a fraction of a degree when you leave Earth, you will miss Mars by 1,000,000 miles. So the orbiter would occasionally fire its thrusters to adjust its path. Every time the thrusters fired, the Lockheed Martin software would send a file to the NASA computers in California, detailing how much force was used. Imagine the data transfer. The orbiter computer says, I just fired the thrusters with a force of 10. NASA computer receives the data and thinks, excellent. It fired a force of 10 newtons. But the orbiter actually meant 10 pounds of force. For the record, 1 pound of force is equal to 4.45 newtons. Which means every single time the spacecraft adjusted its course, the navigation computer was wrong by a factor of 4.45. It wasn't a massive sudden error, it was a microscopic creeping hallucination. It was a slow-motion car crash that took 9 months to happen. The navigators at JPL actually noticed that something was weird. The spacecraft kept drifting slightly off course. They had to keep making manual adjustments to fix it, but because the faster, better, cheaper mentality, the team were understaffed, overworked, and operating in silos. When the navigators raised concerns about the weird trajectory data, the concerns were dismissed. They assumed it was just minor solar radiation pushing the spacecraft or a slight asymmetry in the thrusters. They were so confident in their multi-million-dollar machine that they completely ignored the fundamental rule of troubleshooting. Check your math. They were flying a spaceship blindfolded, relying on a GPS that was speaking a different language, and Mars was getting very, very close. September 23, 1999, arrival day. The plan was simple. The Mars Climate Orbiter was supposed to approach the red planet, fire its main engine to hit the brakes, and allow Mars gravity to capture it into a stable orbit. To do this, the spacecraft had to skim the upper atmosphere of Mars at a very specific, carefully calculated altitude, 226 kilometers or 140 miles. If it were too high, it would bounce off the atmosphere and be lost in deep space forever. If it went too low, the friction of the Martian atmosphere would tear it apart. The minimum survivable altitude of the spacecraft was 80 kilometers. Anything below that was a death sentence. As the orbiter approached Mars, it went behind the planet, cutting off radio contact with Earth. This was expected. The scientists at the JPL sat in their control room, wearing their polo shirts and headsets, waiting for the spacecraft to emerge from the other side and send the signal, confirming it was safely in orbit. They waited, and they waited, and they waited. The signal never came, because the Mars Climate Orbiter wasn't in orbit. It was currently raining down on Martian surface as a shower of molten aluminum and burning circuit boards. Because of 9 months of accumulated metric to imperial conversion errors, the spacecraft's navigation system was completely hallucinating its actual position. It thought it was at a safe altitude of 226 kilometers, while in reality it hit the Martian atmosphere at an altitude of 57 kilometers. At that depth, the atmosphere is thick. The spacecraft, traveling at over 15,000 miles per hour, slammed into Martian air like a bullet hitting a brick wall. The aerodynamic stress instantly ripped the solar panels off. The friction superheated the metal, turning a 125 million scientific marvel into a spectacular, brief, and entirely useless meteor. It vaporized. The atmospheric void consumed it in a matter of seconds. When you lose a 125 million taxpayer-funded spacecraft, you can't just shrug and say, oh, space is hard. You have to do an autopsy. NASA launched a massive, humiliating internal investigation. They combed through millions of lines of code. They interviewed the engineers. They checked the telemetry data, and when they finally found the error, the collective egoid of the American scientific community collapsed into a black hole of embarrassment. They had to hold a press conference and explain to the world and to the United States Congress that they didn't lose the spacecraft because of a complex aerodynamic failure or a faulty microchip or a solar storm. They lost it because they forgot to multiply by 4.4. It was the ultimate humiliation of American exceptionalism. The United States is one of the only 3 countries on the planet that still refuse to officially adopt the metric system, the other 2 being Liberia and Myanmar. You cling to your feet, your inches, and your pounds out of pure, stubborn national pride. And that's totally fine and okay, but that pride literally burned up in the atmosphere of another planet. The Mars Climate Orbiter disaster became an instant legend in the engineering world. It is now taught in several freshman physics and computer science classes on Earth as an ultimate cautionary tale. It proves that if you can hire the smartest people in the world, give them limitless budget and build the most advanced technology in human history, but if you don't establish a basic standard of communication, you're just building a very expensive bomb. The story of Mars Climate Orbiter is a masterpiece of dark, bureaucratic comedy. It strips away the romantic sci-fi illusion of space exploration and reminds us that at the end of the day, rocket science is still just a bunch of stressed-out humans staring at the computer screens, drinking bad coffee and making typos. We like to think the technology will save us. We like to think our machines are smarter than we are. But machines only know what we tell them. If we tell a machine that an apple is a banana, the machine will confidently, flawlessly and efficiently fly itself directly into the planet. The universe does not care about your corporate structure, the universe does not care about your faster, better, cheaper management philosophy, and the universe definitely, absolutely does not care about the imperial measurement system. Physics is a ruthless, unforgiving auditor, and it degrades in metric. Next time you make a mistake at work, or next time you send an email with a typo or forget to carry a zero on a spreadsheet, take a deep breath. Forgive yourself, because unless your typo resulted in the atmospheric incineration of $125 million interplanetary spacecraft, you're doing just fine. Stay strange, stay sharp, and for the love of God, check your units. See ya.